Hi, kiddos. So sorry I was late. I got caught in some traffic, and then I had somebody that needed to. Hi, kiddos. So sorry I was late. I got caught. Turn off the sound because I'm watching the video also. I also had some guy that needed to come over and do some repairs on my house today, and so I got kind of slowed down on that. You guys can see Gabby's email to me. That's funny. I'm going to quickly turn off notifications because otherwise they're going to be popping up. But as I do go turn off notifications for things, I'm also going to type, if you guys have any questions. Actually, first of all, let's start with, please type your first and last name. If you guys look to the right of your screen, Lucy Epram helped me last time when I had one of these, saying that you might not see the chat right away, but if you make a channel, it's no big deal. You can just kind of do like create channel. It can be through your Heritage Warriors email, no big deal. But I'm going to have you type your first and last name just so I can see that you're there. If for any reason you can't get it to work, don't worry, just email me your first and last name. It's kind of like me taking attendance. And if you're watching this at a later date, you can also email me your first and last name just so I know that you are here or that you watched it. Hi guys, hi Jason, hi Caroline. But then also, I'm also gonna have you guys start typing because the chat has a bit of a delay. I'm also gonna say if you have any particular questions on the packet, please type them as well. And I'm also gonna pull up my email, so once again, if the chat's not working and you guys have anything to ask, if anybody wants to text Gabby real quick, something weird is going on with her being able to access the videos, and you guys might be able to help a little bit better than I can. I don't know what's going on, but something or others is kind of funny. But go ahead and type any questions that you have, and meanwhile, let me turn off these notifications super fast, because otherwise, everything's just going to be popping up all the time. So let's turn off that real quick. Let's see what else. Let's turn off messages so you guys don't see all my texts. Not that I get that many. What else? Gmail, let's turn off those ones. So people are writing in, you guys don't see all that. And I think that's it. I don't think I have Facebook. Oh, I do have Facebook turned on. We'll turn that one off too. Okay. I have on my iPad the summer packet. And if you guys watched the other video, if you haven't, you can click on the link. Sorry, my dog's going to be a little noisy because I just got home, so he's getting attention. Hi, Bubs. But if you click on the other video, there were some questions that we did already answer. So I'm just kind of looking for what questions you guys have. And I have the work of the other questions we answered already in the packet, so I can go a little bit more over them if that would be helpful. Or if you guys don't have questions, if someone else does, like one of your friends that they want to see. I don't know if Gabby has any questions she wants to see. I'll ask her really quickly. Normally, she's able to watch mine. I'm asking Gabby if she has any questions too. Then after. See if she has any questions in the packet. Any questions? So I'm not used to having to be places certain times. I have to get used to this. With school coming. Jason and Caroline, do you have any questions, kiddos? If so, go ahead and throw them in the chat. Or if anybody else who's joined, just go ahead and follow the directions. If you can't see the chat, I'm looking for first name, last name. Hi, John. Looks like you guys had fun in Mammoth. That was super recently, wasn't it? I'm trying to think if there's anything weird. I'll give a quick announcement as you guys are typing. Remember, there's a delay on my chat. So if you could type whatever problem number, or if you want to do page number, I guess that would work too. Anything that you're stuck on or you don't quite understand the answer key for, or maybe one of the problems that I did on the last study session that you want to get a little more detail on. Feel free just to throw it in the chat, or once again, you can email me, just mduick@Heritage Schools. And I should be able to get it. But my quick announcement was there were some people that were confused. I think, oh, Jason, it was you. Noah was talking about you guys were confused about part 2 of the packet. of the summer packet. Part 2 is literally just me telling BC kids or current BC kids. Gabby didn't have any questions. Telling current BC kids, sorry, AB kids from last year who are going into BC, hey, integration is not on the packet to review. Oh, I see that, Jonathan, 102. Okay. Where was I? Integration is not reviewed on the summer packet at all. So going to Khan Academy and maybe peeking at some of the integration stuff that you didn't like or that you were a little bit weak on last year would be maybe kind of helpful. So I was just kind of showing Khan Academy. I was giving links for it. Same work, but why is the final answer DNE? Okay, Carolyn, I see that. So for BC kids, sorry, AB kids from last year going into BC, there really is not a lot of additional work for part 2. It's literally just go check out some of your most difficult. It doesn't even have to be integration, just that's not covered on the summer packet. And we are gonna go super quick through Calc AB stuff, kind of like a college class would, like the short and sweet version, and go in depth on a couple things as we head towards the new BC topics. But Calc AB, just kind of go find on Khan Academy, I don't know, 2, 3, maybe even 4 topics that weren't your strongest, maybe even just 2, and do a few practice problems on it. And then the big thing, part 2, is for kids who want to skip into BC from honors pre-cal, like a Gerardo. He had to do tons of work last summer as far as watching all of those videos just to give him, or to get him kind of up to speed with some of the Calc AB kids. Okay, I'm going to go ahead and start with number 5. Yeah, number 5, right, Caroline? Good. Okay, so number 5, it's talking about compositions of functions. No, not compositions, I apologize. Linear combinations of functions. Noah Lee is present. Noah, you're back. Hello, part 2. Noah came to the AB and the BC last time, which was fun. Let me get my red pen up. Okay, the long story short, you have to be careful of this function notation. When you see the f plus g, you have to think about of -3. So think of f of -3 plus g of -3. Now, some of you guys might go ahead and think about, hey, it's f of x plus g of x, then plug in -3. And I understand why you would do that. And in Caroline, that might be how you got an answer, is that you were thinking, I need to add these 2 together, then try to plug and chug. Oh, I should turn my phone off because you guys are hearing on my Snapchat. Okay. But if you try to plug in separately to f and to g, you got to be careful because this f has a square root. And so if you have -3 minus 3 plus plugging in -3 into the g function, so it's -3 quantity squared plus 5, right here is our DNE. Because -3 minus 3 is square root of -6. Square root of a negative does not exist, so even though there is a component or a part to this that does exist, we have to say, no, 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 square root of -6 is impossible, hence why we go to DNE. Caroline, give me a quick, like, hey, it makes sense. All about the square root, all about the can't have a square root of a negative number. And then number, I think it was number, does that kind of make sense? There are a few different ways that maybe you thought you could have kept going, but yeah, as soon as we have a square root of a negative, we're done. I'm going to go ahead and go over to Jonathan's 102. Anybody else who has joined us in the last few minutes, I see that there are more watching than, well, basically were before. Just go ahead and type in the chat on the right, first name, last name, if you haven't yet. If you're watching this at a later time, you can go ahead, or even if you're watching and you can't figure out the chat, you can send me a quick email with first name, last name, and any questions that you have. Just give me the number of it. I'm going now to Jonathan's question on number 102. This was on the parametric polar. AB kids from last year, we did cover parametric and polar a little bit in pre-cal, if you took me with pre-cal or for pre-cal. So that might be something where you might want to locate those notes if you have them and didn't throw them away. And just kind of realize that you're going to want them eventually. I mean, right now in the summer packet, it's really just an introduction. It really is. But it is going to come back a little bit first semester, mostly at the end of second semester. But we will see, we will deal and play with parametric and polar equations. So just a quick heads up on that. When you see the directions, eliminate the parameter. We'll get back to stating the endpoints. Well, we can put that too. State the endpoints. You have to think about what is the parameter. The parameter is just a special name for the variable t. I felt like I did this one with, no, did I do this one with you? I felt like I did, but it's not there. Anyway, we want to eliminate the parameter t. The parameter is just a special name for that extra variable t. Remember, in our calculators, if you were to do this, you have the x of t and the y of t, two functions. Sorry, I moved the screen a little bit. X of t, y of t. Whenever we want a function, we want to get y by itself. And when they say eliminate the parameter, they want y equals f of x. So they want y as a function of x. In order to get y as a function of x, it has t right now. We need to get rid of the t. Think in math. How do you get rid of something? Substitute. Substitute, well, I need an expression for t. Well, we've got to go look at this other equation and say, hey, if we get t by itself, add 3 to the other side, plus or minus square root, we have x plus 3. If we have t, an expression for t in terms of x, we're golden, because all we have to do is take this expression, plug and chug it into the y equation, substitute it on in. So now we have y. Remember, that's our function. We're going to plug in, sorry, you're going to hear trumpet. I have a neighbor that plays trumpet. Well, technically roommate, I suppose. When you plug in plus or minus square root of x plus 3 plus 2, we have our final function in terms of x. Now, wow, they're really going for it. Our function is done, but the problem is that we also have this domain restriction up here. And I think I forgot to state the endpoints last time, if I did answer this one before. And if you look at it, my t is in between -2 and 2. So we need to think about, okay, with this parametric equation, t is in between -2 and 2. If you need to, you can actually just go off to the side and say, who is this guy? Like, okay, I see all this stuff, but we're not used to seeing parametric equations and knowing what they look like and knowing where they start and where they stop. So it might be easier to make a table and say, okay, if I'm supposed to go in between, t is -2 and 2, we're going to make a little extra column, a t column, if you want to think about it like that. Sadly, there's not really room for a t column, so let's put it up here. We'll make a little t column. There we go. We're just going to say, okay, -2, this is time. So we're just going to make it simple. We'll just go -2, -1, 0, 1, 2. And we're just plugging and chugging. If we plug in -2, we have to plug it into the x and into the y, sadly. If we plug it into the x equation, -2 squared is 4, 4 minus 3 is 1. There we go. Again, -2 to the y equation, -2 plus 2 is 0. Now that's one endpoint because that's one side of the domain restrictions. We can go ahead and say that is one endpoint. You went over 108. Oh, thanks, Noah. That's right. It was a polar that I was eliminating, not the parametric. Okay. So I have the 1, 0. And technically, we could just skip ahead to what's going on at time t equals 2, the other end of that domain restriction. If I plug in 2, 2 squared is 4, 4 minus 3 is 1. If I plug in 2 to the y expression, 2 plus 2 is 4. There's my other endpoint. Think the endpoints are at the beginning and at the end, since t is time and that's what's restricted. What's going on at the beginning, that's one endpoint. What's going on at the end, that's the other endpoint. So we could say that our endpoints, oh, I forgot to open up my answer key. The endpoints are at 1, 0 and 1, 4. If you wanted to, you could go ahead and maybe assume. No, I don't think you could assume. I was going to say you could try to make like a domain restriction with the x values, but that's going to be messy also unless you keep on going and plugging in the other points. And they did say state the endpoints explicitly. They didn't say give the domain. So technically those are the endpoints. Let me go ahead and quickly, if you guys haven't, I mean, hopefully if you knew how to get here and get to the online math lab, that means that you read the directions on the website. On my website underneath Calc BC Summer Assignment. But in case you didn't see, for some reason, the answer key, I'm sure you guys all did, but that's where I'm going. We're going to the answer key real quick for number 102. And making sure that that's what I thought earlier when I did this problem. Yep, 1, 0, and 1, 4. I just gave a little bit more of the rationale maybe with my table, trying to show why exactly I was doing at -2 and at 2. It's because of this restriction right here. So anyway, there we go. John, just let me know, write a quick, like, hey, it made sense, and then we'll be good. Got it, cool. I'm looking back really quickly to see if anyone else had any other questions. Jason, Caroline, John, or anyone else who's joined us in the meantime who hasn't put first name, last name? I guess there's only 5 watching. I'm one of them. And then Noah's 2, John 3, Caroline 4, Jason 5. Maybe it's just us, guys. I am so proud. I should give extra credits to the kids that actually came. You know what? To that end, I'm going to write your guys' names down. All right, as I write names down, for the kiddos that get the extra credit, if you guys have any other questions, let's see. Noah came to the first one. Lucy came to the second one. Noah, just for sake of argument, I'll say ×2 because he came twice. John came. Gabby tried to come, technically. She just couldn't get her computer to work for some reason. Caroline came. And then Jason, you're here. We'll put Gabby in parentheses. She really tried. There we go. Some people might have tried a little bit earlier, sadly, but I was in traffic. Oh, perfect. 27C and 40. Thanks, John. Dun, dun, dun. Okay, 27C, I did talk about. Don't worry, I'll still kind of go over as to what's going on, why it is what it is. But for number 27, I did go over it in the other video. So if you haven't checked that out, that might be a good place to check out. Also, I kind of talked more through 27 and how it's called logistic and all this sort of stuff. Let me just kind of, if I can get my pen back. There we go. Maximum number of elk, you have to look back in the equation and say, okay, which variable stands for number of elk? E, no, of course not, that's a number. So forget that one, that's not even a variable. T, oh, nope, that stands for time, which I think is measured in years. Yep, according to our problem. So what stands for the number of elk? Number of elk is gonna be P. Doesn't explicitly say it, except it does say the number of elk. So think, okay, so population, number of elk, okay. So P is my function, population, number of elk. So it says the maximum number of elk possible. I got this first expression by just saying, okay, what is the number of elk? P. Okay, I want to take the limit as t goes to infinity, idea being, it might be a little hard if you don't know what logistic growth looks like, or, well, 2 things. If you don't know what the equation looks like for logistic growth or the actual graph itself. We will talk about this in a lot more detail this year. But long story short, logistic growth looks exponential, except that cannot possibly continue forever. Eventually it stabilizes. Eventually it levels out to some limiting number, or limiting constant. So as a result, since it levels out, we can say the maximum number is going to be basically that horizontal asymptote, is going to be that height, which is the same thing as t approaches infinity. So that's why I'm taking the limit. That's why I'm doing this work over here. In order to do that, I just think about, okay, who is p? Well, it's the function 1216 over 1 plus 75 e to the negative 0.03 t. What I did right here is say, hey, wait a minute. If e is to the negative power, that's confusing. Remember, we're not used to seeing e to the negative power. So in order to change the expression, what was 75e to the negative 0.03? Yeah, 0.03t. Instead of leaving it as it is, we say, no. A negative power, we know what that is. We took algebra, right? That is meaning that power needs to be in the denominator. Oh, excuse me. So we pop that puppy down in the denominator, that e expression, that exponential expression, and then we say, okay, now look at it. And if I'm taking the limit as t goes to infinity, go find the t, he's right there. Okay, if t goes to infinity, that whole denominator is getting big. Well, wait a minute. We know degree tests. Look at this expression right here. If the denominator wins, that whole expression is going to 0. If that whole expression is going to 0, then we say, oh, okay. taking a limit, replace it with 0 and say 1216 over 1 plus 0 is just 1216. 1216, my chat is trying to help me. 1216 is the limit. 1216 is, don't type anything down, thanks. The horizontal asymptote, 1216 is the maximum number of alpha possible. John, let me know if that makes sense. Once again, this is a new type of function. Last year we talked about all sorts of types of functions. We talked about, well, we reviewed real quick and went into more detail of lines, of parabolas, of cubic functions, went into all the trig, sine, cosine, tangent, cosecant, secant, cotangent, went into exponentials and logarithms and a little bit of transcendentals. Well, those are the transcendentals. But we did not talk a lot about logistics, so don't worry. More work on logistic is coming this year, and this is just like an introduction. Got it. Number 40, let's go check him out. Ooh, it's a T-proof. Go team. I like T-proofs. The very first thing I see in these T-proofs is a messy left side, definitely starting with that guy. But I also see denominators that are not the same. I'm guessing you guys probably don't have tons of questions on the ones around this, so I'm going to go ahead and just use all this space. I'm going to go ahead and just pretend this is under the T. I'm starting with the right-hand side. I'm trying to make this expression I'm about to write equal to cosecant of theta, which is the same thing as 2 over sine of theta. I'm starting with sine of theta, all over 1 minus cosine of theta. Now, just so you guys know, there are not tons of T-proofs in Calc BC. It's kind of sad, actually. But kind of like you saw in Calc AB, there are times when, especially in Calc BC, actually, more than AB, there are times when knowing your trig identities and being able to do a little bit of manipulation or a little bit of math with them is going to come in handy. So that's kind of what this is supposed to be helping you prepare for. We want a common denominator. So looking at our common denominators, I see 1 minus cosine over there. I see sine over here. So I'm going to go ahead and multiply by whoever's missing. Which on the left is sine. On the right is 1 minus cosine. And after you check this out, hopefully you see those denominators will now be the same. So this addition will be legal. So we end up sine squared all over. Now I'm going to combine those denominators. They're the same. So sine of theta times 1 minus cosine of theta. And then I have sine squared plus, if you guys check it out, I have 1 minus cosine times 1 minus cosine. Well, I can just make that 1 minus cosine of theta all squared. Now I have a common denominator. Things start to get a little bit messy unless, now I'm running out of room, but if you check it out, maybe you realize there's not much you can do in the numerator except, well, squaring something. Hopefully we got that. Squaring a binomial, let's do some foiling. I'm going to go ahead and undo this guy and say maybe I shouldn't have written that as 1 minus cosine quantity squared. Maybe I should have just actually done the work. So let's do our foiling. 1 times 1 is 1. Outer and inner is a negative cosine and a negative cosine, so a negative 2 cosine. And then last is going to be plus cosine squared. Now there was an addition, so I didn't have to do any like parentheses and distributing a negative. If it was a subtraction, we'd be in trouble if we didn't get those parentheses in. But as you guys are checking this out, hopefully you zoom in pretty quickly on sine squared plus cosine squared. And we know sine squared plus cosine squared is 1. There's another 1 already chilling, so 1 plus 1 is 2. So I replaced sine squared plus cosine squared. Hi, Austin. I replaced sine squared plus cosine squared with 1. 1 plus 1 is 2. And I still have my minus 2 cosine theta. If you guys notice, you're like, wait a minute, 2 minus 2 cosine theta, psh, we can factor out a 2, and you're exactly right. And if you notice, this is quite nice, because now I have a 1 minus cosine theta on bottom. Let's get rid of that guy. Let's get rid of that guy. 2 over sine. Dun, 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 because that's 2 cosecant. Austin, I think you just joined us. If you have any questions, just throw the number in. off to the side, and I'm just kind of going in order, but we just finished Jonathan's, so I am prime and ready to go if you have another one. P.S. everybody, happy you still have a few more days. You have 1 week from today, huh? Left of summer. Some of you guys are like, yeah, but I'm practicing. Well, I'm sorry, but a little more time. Hopefully you did some of your summer work this summer so you don't have to spend all that time working. It makes sense, good. Chapters on. My dog just wants to go play. Any other questions? If you guys didn't check out the other video, some of the problems in this document, like you can tell, number 42 has my work on it, but definitely didn't do it tonight. That was done in the other video. If you click on it, you can watch it. The one that I taped on chat. Out of the way. What was that, Noah? Friday afternoon. Otherwise, we're good to go. Ooh, Austin, I just realized, hold on, you're showing up to the Calc AB session. This is Calc BC session. I'm just about done. I got stuck in traffic, and so they started late. Go back to the email and click on the Calc AB session. I'm just going to be leaving the BC one soon. Noah, if you want to, you can come on over again. But BC kids, once we're done here, you're good to go. And Austin, then I'll switch over to the Calc AB one. There should be a link in that email I sent. Yeah, poor guy. That happened in the other one too, actually. Someone else was like right on time. I'm like, oh no, I'm almost done. But yeah. You're probably looking at this packet being like, what on earth are you guys talking about? All right, everybody who is in the Calc BC, all my BC kids, if you are good, just say good real quick. If you are good, just say good. That way I know that there are no other questions coming. As you guys do that, I'm checking out real quick whether or not the Calc AB photos started working. Not photos, videos. You guys remember last year, the drivers and the diners, those videos are being super temperamental right now, so they're having a really hard time watching them. I think the guy's website the videos keep crashing or something weird is going on. So they were working at the beginning of the summer, but not now, which is really sad because I liked how that guy explains things, but he just can't keep his website working. I think he needs to use Google Drive. That would be helpful. All right, I'm coming back to check out you guys and make sure. Jonathan's good, Caroline's good, Jason's good, Noah. I'm just assuming you're good because I know you are. And I'm good too. All right, BC kids, thanks for joining. Thanks for coming to say hi. Thanks for letting me know that you're alive. I'm excited for this year, excited to get you guys again. And we're gonna have some fun. The cool thing is AB is pretty stressful. Not that BC isn't, but you've already seen the foundation of calculus and you've learned it. And those things that you were weak on will have another chance, another go at, and that's gonna be good. And it's gonna feel, yeah, it's gonna feel nicer. It's gonna feel, I don't know about simpler. Hard thing is second semester when you're like ready to check out, I'm like, oh wait, this is new, focus. But it's gonna be better. So, and for those of you guys that like, oh, AB wasn't hard. Well, you know what? This won't be either, as long as you don't get senioritis, as long as you don't get super distracted with all other life and decide never to do your calculus homework. Talk to George Corey. Anyway, so love you all, and I'll see you guys, Lord willing, on Monday, unless I see you guys early. Some of you might be coming for, oh, Jonathan, yeah, you'll be there Thursday. Anybody else might be there Thursday. Noah, you will be too for ASB, huh? But otherwise, I will see you guys later. So I'm going to go ahead and shut this one down so I can get AB up and running, and I'm glad you guys came by. All right, see you guys later.